Welcome back, everyone. We are doing another Frog microcontroller beginner video. This should be video 3 in the series, even though it is project 4. It is the third lesson. And today we are going to be learning about the piezo speaker. And so a pretty place to start then would be to identify on the frog, transition your view here to the frog itself so that we can see the speaker on the frog. Again, this is nice compared to some of the other boards out there, is that this particular thing has so much, auxiliary things built right onto the board, and one of those also includes that speaker. So the speaker in this case is right here on the board, right where my thumb is touching, and so that is where the speaker itself is located on the board. So nice that you don't have to attach any auxiliary items, or you don't have to breadboard to get a speaker enabled. It's right there for you, so that's really convenient. So let's jump back into what is a speaker, piezo speaker, and then just a reminder where you're going to find everything that we're going to be working from today. So just a reminder that all of the items you need will be located on firstmakerspace.com, our website, and then from there you will go to the resources tab across the top. When you hover over it, you'll see many things pop up, but specifically you want to go to the microcontroller trainer resource hub. And when you click on that, it will take you to where all of the items, including this video, are located. And specifically today, we're going to be working under the interactive projects. This is one that is a little bit farther down the list, so you will have to click View More Projects on the web page to load more of them, including lesson or project number 4, using the piezo speakers. So if you want to go ahead and, if you're following along, click on that. And the engineer, Nick, who designed the board and these projects, was kind enough to help us out here by defining the piezo speaker, or maybe more appropriately called a buzzer. And so we'll start with defining that. So the speaker creates sound through the rapid physical deformation of an internal crystal. When a voltage is applied, the crystal changes shape. So by quickly fluctuating the applied voltage, a sound is generated with a frequency that matches the rate of these voltage changes. So here in a minute, we're going to talk about this concept of frequency. We'll define it, and we'll also do a brief calculation, but it's very relevant because the frequency is going to determine what you hear. So for example, and I already programmed mine, of course, that sound you heard when I pressed the speaker, or the button to activate the speaker, is 500 hertz. And that's exactly what we're going to calculate the frequency here in a moment. All right, so of course you can change the frequency and do different calculations and write the program slightly differently so that you can hear those different frequencies. So that's what a speaker is. And so if we come down here on the lesson and look at that concept of frequency, frequency by definition is the number of cycles per second. And we defined frequency, or the unit used for frequency, is hertz. And so you will see that here on the screen, the abbreviation capital H lowercase z. So when we talk about frequency, the result that we get is defined or used with the unit hertz. So turning it on and off is considered one cycle. That is also important because remember, it's the number of cycles per second. And the cycle can also be called the period. So when you hear that word period, it is the cycle. Okay, so let's take a look at the example here. It says, in our case, the period is 2 milliseconds. So remember, the period is the same as the cycle, and that's the amount of time it takes to turn on and off one time or complete one cycle. So period is 2 milliseconds. How many of those cycles happen in 1 second? And then as a helpful hint or reminder, Nick also provided that 1 second is 1,000 milliseconds. So that should also help you with your calculation. So kindly again, Nick goes on to help you solve it. So if we take the 1,000 milliseconds, or 1 second, divided by the 2 milliseconds that it takes to complete one cycle or one period, our answer is 500 hertz. So again, when I hit that buzzer earlier, the frequency you heard was 500 hertz. So that concept of frequency is really important with the speaker. So let's hop up to our code. So at the very top, you'll notice he again shows you the speaker up here on the board itself, and then goes into the program. So remember that your Arduino IDE is going to, when you open a new sketch, it could have, when you launch the program, it could still have your code from the last time you were in the IDE, or more often it will have this basic setup and loop function already written in there for you. Just a reminder to go ahead and delete that out so that you truly have a blank screen, because when Nick wrote the code, he did go ahead and include those already in there. So just make sure you delete either your previous code or the little bit that automatically launches in the screen, because when you hit copy on the project code, you'll notice it's already there. So I'm going to hit copy. Yes, it's okay that it's on my clipboard. I'm going to go back to my Arduino IDE, and I'm going to simply paste the code that I just copied into the platform. Another reminder is, since this is considered kind of an auxiliary tool or piece of equipment, reminder that you may need to go into your managed libraries and make sure the library for the speaker is activated. Mine already is, so I won't need to do that. But just a reminder, hey, if I pushed the code and nothing happened, or it gave me an error, it could be that your library needs to be added. So again, I just do that under Tools and Manage Libraries, and then I would just search for the Piezo speaker and make sure I install that particular library. So mine's already done. I won't need to do that. Also, just a reminder that you do need to make sure that your appropriate communication or COM port is selected. So in my case, it happens to be COM8, and it has the Arduino Leonardo, which, as you may recall, is the platform that our Frog controller trainer is built on. So I have my code copied and pasted, my communication port selected. I can go ahead and hit the check mark and verify my sketch, and I will move me out of the way so that you can see it. And notice it says done compiling. It didn't give me any errors, so that tells me I'm probably having a high chance of success. So at this point, I'm going to go ahead and tell it to upload to the Frog itself, and I'm going to transition you over to the view of the Frog here. And I'll probably go ahead and hit that button again, just to remind you that you'll know it's doing something because it should start blinking when you go ahead and hit that upload. So notice I have an LED blinking now on my Frog. That tells me it's receiving some code. And then you can't see my screen any longer. Sorry, yes you can. It says done uploading. So that tells me that my Frog should be ready to go. And sure enough, if I press switch 1, my buzzer activates. And we know exactly what frequency because we calculated it at 500 hertz. All right, so again, I realize this is very beginner, but we have to learn how to walk before we can run. And so another very simple lesson just to show you what the Frog is capable of and what some very simple program would look like in order to get the Frog to do certain things. Remember, you can always modify the sketch slightly. So maybe try calculating some different frequencies. Maybe another thing you might try is, instead of telling switch 1 to control the speaker, maybe try having switch 2 to control the speaker. So there's things that you can do to slightly modify the code so that you can see that you can change just slight things in the program to have a different function. So hopefully this was a very straightforward and simple lesson to you, and we will jump over to NeoPixels in the next lesson. Thanks for joining. This has been Megan Ewing.